take out a highlighter. Sometimes when we add up an infinite amount of numbers, it approaches an answer. And when it does this, we call this sum a sum to infinity, and we call the series convergent. So our first question, what we're going to look at is which one of these do we think approaches a number that would have a finite sum? And the idea behind this is that if you start to add up smaller and smaller and smaller bits each time, maybe you're going to get close to a number. So for A, first of all, in A, you see that R is 1/4, that you would multiply by 1/4 to get the next term. If you kept on going, you see that the numbers that you would add get smaller and smaller and smaller. Okay? Eventually, you're going to be adding numbers that are basically so close to 0, we'd say they're 0. So for A, we would say that it is all right. Did anybody add up the numbers that are there so far? See what you think it would equal to? No? Not quite yet? Okay. Oh, thank you. All right. So no one's added up the numbers. I think it tends to, does it get close to 0.4? Does it get higher than 0.4? 0.4427. Okay. That's where you got up to? That's our estimate. I'm going to tell you that it adds up perfectly to 4/9. Oh, what a beautiful number. Did you know that 4/9 is 0.4 repeated? Such a beautiful number. Did you know that all of the ninths are repeated like that? 1/9.1 repeated, 2/9.2 repeated, 3/9.3 repeated. Do you know what 9/9 is? 1. But it's also 0.9 repeated. Oh my goodness. Is it? Okay, we'll finish this question, then I have to get off topic because there's some really cool math we can talk. We'll finish this one first though. Okay, so B, we'll do it quick because B is boring. Can you see that you're multiplying by 2? Do you think that's going to get close to a number if we keep adding bigger and bigger numbers? Or do you think it'll just keep getting bigger and bigger negative numbers in the end? Yeah, so this one we would say is divergent. And in C, oh, it's changing from positive to negative, so that makes our R value -1/10. And in this one, those numbers are getting closer and closer to 0. So your sum is going to get closer and closer to a value. Or you're going to start with 1/10, then you're going to subtract, then you're going to add, then you're going to subtract, then you're going to add, then you're going to subtract. Okay? Any guesses on that one? Seems to get closer to 0.0909, which is also a cool number. We'll talk about that one. Yeah, I think we can get off topic. Did we answer the question? We estimated it. And you could estimate it by adding up the 5 and actually get an answer from your calculator and say, that's probably pretty close because next time I'm going to add 1/100,000, which is not very big. Okay? Next time you want to know how big 1/100,000 is, think about sharing something with 100,000 people. And then whatever you're sharing, a piece of cake, actually cut it in so everybody gets the same amount. They're going to get next to nothing, not a very big amount at all. So we'd be very close to zero. Now, what I wanted to get off topic is the beautiful numbers. Now, 1/9 is 0.1 repeated, 2/9, so nice as a fraction, 0.2 repeated, and so on. And you might be like, oh, isn't it interesting that 3/9, which is 0.3 repeated, is also 1/3, because we could reduce that fraction, and so on. But then we get to 9/9, and should it be allowed that we should be able to write 9/9 as 0.9 repeated? Or is that a mistake? And as Hunter said, it's 1, which it is, right? 9/9 is 1. So sometimes I start this argument on which is bigger, 0.9 repeated or 1. Okay? And the gut feeling is you would want to say that 1 is bigger than 0.9 repeated. But I'm going to show you that they're actually the same number written differently. Now, I'm not saying now from now on in your science classes, when you get an answer and your answer is 3, that you decide to write 2.9 repeated instead and then argue with your teacher when they take off marks. Okay, this is not a good idea, but those two numbers are the same. And I'm going to show you with 3 different explanations of why they're the same, and you can discern which one is the best explanation. Now, explanation number 1 is here. Well, 1/9 is 0.1 repeated, 2/9 is 0.2 repeated, then 9/9 is 0.9 repeated, and people go like, ha, 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 ha. That doesn't seem very convincing. Okay? But what happens if I actually did want to say they're the same, and I know that 1/3 is 0.3 repeated, and I know another 1/3 would also be 0.3 repeated, and I know another 1/3 would be 0.3 repeated. And if I add these all up, well, obvious the fractions, 1/3 plus 1/3 plus 1/3 is 3/3. You know that that is 1. But if I add up the decimals, you see I never have to carry anything over. There's 3's forever. They'll all line up. And you'll never have to carry over a 1. Can you see that there'd just be a whole bunch of 9's all the way through? Okay, so that might be a little bit more convincing, that 1 should be 0.9 repeated and be exactly the same. But I'm going to end off with an algebra one. I'm going to start with x being 0.9 repeated. If you took x and you multiplied it by 10, that would just move your decimal place. Would you agree on the number side? You would have 9.9999999 forever. And then, on this side, I'm going to subtract x. And on this side, I'm going to subtract x as well, which means I'd subtract the 0.9 repeated. And this should be easy math for you, right? That all those decimals would go away. On this side, these are like terms. So I get 9x is equal to 9. If I want to get x by itself, I'd have to divide both sides by 9. I get x is equal to 1. But what did I start with? I started that x was 0.9 repeated. And I ended up getting x is equal to 1. They're the same thing. Now mathematically, for two numbers to be different, there's always going to be a number in between them. If two numbers are different, you can always find the average and put a number in between. There is no number in between 0.9 repeated and 1. They are the same number. That is, okay, a little bit crazy. So, all right, so questions for this one. Oh, this one is actually 0.09 repeated. And if you have two numbers repeated, you can always change that to a fraction over 99. And three numbers repeated over 999. And so any fraction that's repeated over a certain amount, you can change it to 999. Okay. All right. Oh, I didn't give you the questions. Just 3 and 4.